Okay, now let me sum up what we have done here. As you can see, when I talk, the OLED screen shows a reading of how strong the signal is and how this is accomplished. We have a max audio variable that finally gets the strength of the signal, and then we display on the OLED screen a rectangle. The rectangle is on pixel number 10 to the right, on pixel number 30 to the bottom. The length of the rectangle is the strength of the signal. That's a VU meter. That's what a VU meter does. And the thickness of the rectangle is 10. Okay. We could put the rectangle on pixel 0, and I will do this right now. Okay, I'm uploading now the program. Let's go. Doing it on number 10 here. The beginning of the line now went at the beginning of the OLED screen. Okay, that's what I did wrong before. I had here 10, so it wasn't from right from the left, it was number 10 pixels to the right it started. Okay, so we have seen that we have put the strength of our signal, which is here. Okay, and we have this max audio variable according to the strength of the signal, which is here. The numbers are here, and these numbers are shown on the OLED screen as length of a line. Okay, now I have to explain a little bit more. Now what I tried is to show something that looks like a VU meter very quickly, but we have now to learn a little bit more how Arduino reads and manipulates analog signals, so voltages. The Arduino is receiving voltages. The voltages are received on an analog input pin of the Arduino. In our case, as we can see here, okay, it's the pin A0. So the analog pin of the Arduino measures voltages from 0 to 5 volts. What it does is that it outputs a number from 0 to 1024. So if the voltage that it reads is 5 volts, it shows let's say 123. If it's 0, it shows 0. If it's 2.5 volts, it shows the middle of 0 to 123, so 512. Okay. Our analog signal is something like 0 to 1 volts. So that's why the readings, as we can see here, they never reach more than 120, 150, because the voltage it's too low. It doesn't go higher than 1 or 1.5 volts. What we lose by doing this is a resolution of our signal, because the Arduino is trying to read voltages up to 5 volts, but we never reach 5 volts. So there is a way to get over this, so teach the Arduino to read voltages up to a lower number and not 5 volts. How this is done? This is done by a command. Let me show you. This is done by a command which is here. Do you see this command that is called analogReference? This analogReference command has some values here. Let me show you how we can learn all this stuff from the internet. analogReference. Here we are. So what we have here, we can inside the parenthesis here, we can put either internal, which will tell the Arduino to try to read voltages up to 1.1 volts instead of 5. You see, 5 is the default. It shows here. We can also tell it to read an external voltage, and then we have here an A-ref pin. There is an A-ref pin on the Arduino. I don't remember exactly where it is, but if you read the pins of the Arduino, you will see that there is a pin with the name AREF. Okay, so we can put here the value external. Let's copy it from here and put it here. Okay. Be careful when you put the value external, because if you put the value external but you give no voltage to the AREF pin, then the Arduino might get burned. So if you put here external, you have to put a value, you have to put an external voltage on the AREF pin. The Arduino has a power out, voltage out pin, which is 3.3 volts. So you can just take a wire from this 3.3 volts output pin and hook it on the AREF pin. When you do this, the Arduino will read voltages up to 3.3 volts, which is less than 5 volts, and this will increase the resolution of our readings. Let's see. For example, now, as I speak, the readings, I think you can see them, are about 40, 50, 70, 110. They don't go higher than that. But because the reference voltage is 5 volts. I will now hook a wire from the 3.3 output to the AREF pin. So I will change this reference voltage to 3.3 volts instead of 5. I will stop now the video, put this cable, and I will show you then these readings here, how they are. Remember, they are about 138, I saw, somewhere there. Okay, stopping the video, coming back right now. Okay, I brought a wire to use, which is, let me show it here. I brought a wire to use, and I also brought my glasses because I can't look very close without my glasses. It happens with age. Okay, so the 3.3 out voltage is let me see, is somewhere here, and the reference pin is REF, called here on the Arduino Nano, is right next to it. So I will now hook it on these two pins. Okay, that's what I did here. Let me check closer and be sure that I did correctly. Okay, I hope I did everything correctly. Now, so analog reference external. The pin is already connected. As I said, if you put external, don't forget to feed a voltage to the REF pin, otherwise you will damage your Arduino. And now I will upload this to the Arduino again and see what we will get. Done. So serial monitor and ooh, as I can see, the readings are again, no matter how I shout, they're about the same height again. So what did I do wrong? Analog reference external, and I fed 3.3 volts. Don't know. I will change this to internal. So the reference voltage, if you put internal, is the 1.1 volts, as I showed here. You can see the internal built-in reference 1.1 volts. Let's see now. I will take out the pin from the AREF here, like that. And let's see now what values we're going to get. Loading, uploaded. Look at the line now. Tools, serial monitor. Now silence is not like 2-3 volts, and if I shout you see I have much higher values. Ooh. Hello. You see, I even have 400, because now, so as I can understand, the values that I am receiving are generally to the range of up to 0.5 volts or something like that, because with this internal command, the maximum voltage that we read is 1.1 volts, and the Arduino would output 1000 and the value of 1023. If, as we can see, the maximum value is about 540 or something, So we get voltages up to 0.6 volts on the Arduino. Now I will do something that will let me show you. With this, doing it this way, the line goes always very easily to the top. Can you see this? It reaches the end because this max audio goes above 128, which is the resolution of our OLED screen. So if I speak slowly, if I want all our values to be displayed, then I have to do what? I have to, let me show you. I have to interpolate the values that I get and let me show you how this can be done. So whenever I get a value, max audio, what is this command here that I just put? This command takes our max audio variable and maps it between 1 and 600, takes all readings that are between 1 and 600 and interpolates them between 100 and 128. You see what it does? So our highest number, which was about 540, now 540 will become something less than 128. Did you understand this? This is the command map. It interpolates values. You can easily here see. Let me Google it. Arduino map variable. If you do this here, you will see what this map variable does. Okay, maps a number from one range to another. That's what we're trying to do. Now let's see if I do this mapping, what we will finally get. It's done. Ooh. So what happens is that now our reading has higher resolution. Let me just do an online signal generator like we did. I will take out the earphones because it will drive me crazy. I will decrease the output of the computer. Okay. Look at now. I'm increasing the audio of the computer so that it's nearly to the end. Now, if I decrease the volume, the reading on the OLED screen decreases also. And if I increase it, it increases also. You see? This is a representation of VU meter. To make it more fancy, I will fire up here YouTube. I would put some free music, non-copyrighted instrumental music. Okay, there is commercial. Let's go, let's go. Look now. So it doesn't look very nice from the camera because the camera, the frame rate of the camera is confused a little bit with the frame rate of the OLED screen, and it looks like it bounces up and down. But looking at the OLED screen actually with your eyes directly, it doesn't look that bad. But it bounces also a little bit. It's really not very stable. Now as I talk you can see it, but it bounces a little bit. And why does this happen? That this happens because when it takes a high reading, it goes straight to this high reading. When it then has a low reading, it goes straight to this low reading. That's how that's how we programmed our Arduino. An analog needle that shows a reading on a VU meter wouldn't be like that, because it would need some time to go from one point to the other, so it would look like more smooth, and it would not just bounce up and down very quickly. This is a start, this is a beginning so that we learn how the Arduino reads audio and how it represents the strength of the signal of this audio to the OLED screen. Now we have to do some smoothing of our reading so that the representation on the OLED screen looks more appealing to the eye. Okay, doesn't look so doesn't look so harsh. How would I call this? I don't know. Okay. Anyway, I will stop now this video, and I will come at another day or at another time and show you some smoothing techniques. Bye now.